Welcome to this lesson on transformations. Transformations describe how shapes can be moved, flipped, or turned on a plane. This is a key topic on the LANTITE, and you will need to identify, describe, and perform reflections, rotations, and translations. We will also look at combined transformations, where more than one transformation is applied to a shape. By the end of this lesson, you will be able to identify and perform reflections, which are flips across a mirror line. You will identify and perform rotations, which are turns about a center point. You will understand translations, which are slides in a given direction. You will be able to describe each transformation using correct mathematical language, and you will be able to apply combined transformations where more than one transformation is done in sequence. A reflection flips a shape across a mirror line, also called the line of reflection. Every point in the reflected image is the same distance from the mirror line as the corresponding point in the original shape, but on the opposite side. The reflected shape is laterally inverted, just like your reflection in a mirror. Importantly, the size and shape do not change, only the orientation changes. To reflect a point, draw a line perpendicular to the mirror line from the point. Measure the distance, and mark the same distance on the other side. Let's reflect a triangle across the y-axis. The triangle has vertices at A12, B42, and C15. When reflecting across the y-axis, the rule is that x-coordinates change sign, while y-coordinates stay the same. So A at 1, 2 becomes A prime at -1, 2. B at 4, 2 becomes B prime at -4, 2. And C at 1, 5 becomes C prime at -1, 5. The reflected triangle is the same size and shape, just flipped horizontally. There are similar rules for reflecting across the x-axis, where y changes sign, and across the line y equals x, where x and y swap. A rotation turns a shape around a fixed point called the center of rotation. To fully describe a rotation, you need three pieces of information: the center of rotation, the angle of rotation in degrees, and the direction, which is either clockwise or anti-clockwise. The most common rotation angles you will see on the LANTITE are 90 degrees, which is a quarter turn, 180 degrees, which is a half turn, and 270 degrees, which is a three-quarter turn. Notice that a 270-degree clockwise rotation is the same as a 90-degree anti-clockwise rotation. Let's rotate a point. We want to rotate the point P at 3, 1 by 90 degrees anti-clockwise about the origin. The rule for a 90-degree anti-clockwise rotation about the origin is that xy becomes -yx. So P at 3, 1 becomes P prime at -1. 3. We can check this is correct by verifying that the distance from the origin has not changed. The distance to P is the square root of 3 squared plus 1 squared, which is the square root of 10. The distance to P prime is the square root of -1 squared plus 3 squared, also the square root of 10. The distance is preserved, confirming our rotation is correct. Learn the three key rotation rules shown here for the LANTITE. A translation slides every point of a shape the same distance in the same direction. We describe translations using a vector, written as a column with two numbers. The top number tells you how far to move horizontally, with positive meaning right and negative meaning left. The bottom number tells you how far to move vertically, with positive meaning up and negative meaning down. Unlike reflections and rotations, a translation does not change the orientation of the shape at all. It simply slides the shape to a new position. The shape stays exactly the same, just in a different location. Let's practice describing a transformation. A teacher places a letter F at position 2, 3. After the transformation, it appears at -2, 3 facing the opposite direction. First, compare the coordinates. The x-coordinate changed from 2 to -2, so it changed sign. The y-coordinate stayed the same at 3, Second, the F is laterally inverted, facing the opposite direction. This rules out a translation because translations do not change orientation. It also rules out a 180-degree rotation because that would flip both coordinates. The rule xy goes to negative x, y means this is a reflection in the y-axis. Now let's tackle a combined transformation. A shape with vertices A at 1, 2, B at 3, 2, and C at 3, 4 is first reflected in the x-axis, then translated 2 units left. We apply each transformation in order. First, reflect in the x-axis. The rule is xy goes to x negative y. So, A becomes 1 negative 2, B becomes 3 negative 2, and C becomes 3 negative 4. Second, translate 2 units left. This means subtract 2 from each x coordinate. So A prime becomes negative 1 negative 2, B prime becomes 1 negative 2, and C prime becomes 1 negative 4. A crucial point for the LANTITE is that the order matters. If you did the translation first and reflection second, you would get a different answer. Here are common mistakes to avoid. First, do not confuse reflections with rotations. A reflection creates a mirror image, while a rotation turns the shape without flipping it. Check whether the shape is a mirror image or simply turned. Second, be careful with rotation direction. 90 degrees anti-clockwise and 90 degrees clockwise use different rules, and mixing them up will give the wrong coordinates. Third, when doing combined transformations, always apply them in the order given. Reflecting then translating is different from translating then reflecting. Fourth, when describing a rotation, you must specify all 3 parts: the center of rotation, the angle, and the direction. Missing any one of these means the description is incomplete. Now it is your turn. Pause the video and try these 6 problems. Problem 1. Reflect the point 4, negative 3 in the x-axis. Problem 2. Rotate the point 2, 5 by 180 degrees about the origin. Problem 3. Translate the point negative 1, 4 by the vector 3, negative 2. What are the new coordinates? Problem 4. A shape is reflected, and the image is a mirror image of the original. True or false? Problem 5. A triangle at 1, 1, 3, 1, 2, 4 is reflected in the y-axis. What are the new vertices? And problem 6. Describe fully the single transformation that maps 3, 2 to negative 2, 3. Check your answers on screen. Let's recap the key ideas. A reflection flips a shape across a mirror line. A rotation turns a shape about a center point, and you must specify the center, angle, and direction. A translation slides a shape without changing its orientation. All 3 transformations are isometries, meaning they preserve the size and shape of the object. When performing combined transformations, always apply them in the order given because the order matters. For the LANTITE, learn the coordinate rules for reflecting across the axes and rotating about the origin. These rules will save you time and help you avoid errors.